Hello and welcome to another episode of Better Together at Math with Shinrai Sensei. And today we're going over if-then statements and converses. The if-then statement is also known as a conditional, right? Now a conditional statement, conditional whatever for, term or phrase you want to use to describe it, all describe the same phenomenon where you say if A is true, or if in this case P is true, then Q is true, right? And so if-then is equating to what you want to be true statements, right? You're hoping that they're true statements. And if your if-then statement is not true, and the converse is not true, well, then your if-then statement is entirely false, and you can just discard it, right? But you're trying to formulate a correlation and a relationship between two things, and that's really what the if-then statement is about, right? You're drawing a conclusion about two things being true or false based on the the trueness or the falsity of either one, right? So the conditionals, if hypothesis, which is P in this case, then conclusion, which is Q, right? And then the converse is you just simply flip P and Q's position in the sentence, right? So if Q, then P. So if conclusion, then hypothesis. Now, this is obviously, it's only a converse when you display it in a relationship to the initial conditional, right? The first conditional being displayed is the only way to go ahead and show that this is a converse. Because if this didn't have a conditional to relate to, then this if-then statement would be a hypothesis and a conclusion here, right? But since we have the hypothesis and conclusion here, and these are flipped, this is a converse. Okay? I hope that didn't make it unnecessarily complicated, but the examples should help kind of clarify, okay? So first example that we have is if today is Tuesday, then tomorrow is Wednesday, right? And I put in purple right here at the converses beginning, that way you understand that it's a converse. I put conversely, if tomorrow is Wednesday, then today is Tuesday. However, this example, both statements are true. One can be true, though, while the other is false. So, in math terms, if x is greater than 7, then x is greater than 2. Right? That's true. This if-then statement, or this conditional, is true. However, conversely, if x is greater than 2, then x is greater than 7. That could possibly be true, but simply put, it's not true by the virtue of this statement. It has to be proven true through some other means, right? Because just because a number is larger than 2 does not mean it's larger than 7. Because a number can be larger than 2 and smaller than 7, right? We know that. So if x is greater than 2, then x is greater than 7 is not true. So this converse fails while the initial conditional succeeds, right? So this is just some possibilities that you could encounter when it comes to word problems and things like that. These are just some common word problems that you might encounter and ways to read it and things to understand about it, right? And so if I was to say if this staff is longer than 5 feet, then it's longer than 7 feet, right? Well, then, no, that's not necessarily true. But if this staff is longer than 7 feet, then it's longer than 5 feet, right? Then that could be true still, because 7 feet, longer than 7 feet would always 100% be longer than 5 feet. But the other way is not true. So, just some things to know about conditional statements and converses, right? Pretty simple stuff. We're slowly building our way towards getting into actual geometry, so look forward to that. But if you guys have any questions, please leave them in the comment section below, and I look forward to seeing you guys next week. Peace!